Hi everyone, hope everybody is healthy and safe at home. Welcome to day 1 of online instruction. This is going to work a little bit differently than me teaching you in class. I am going to have the worksheets uploaded to my website, which you can find on the staff directory of the East Islip Middle School page. My suggestion to you is to print out the worksheet and follow along with me, write notes as if we were in class as you're watching the video. You're not really going to learn much just by watching or skimming through this video. At the end of each class, or at the end of each video, I am going to have posted on my website a little quick check, a little classwork assignment for you to make sure you understand this stuff, and that's how you're going to be graded in this class. I will post more information about that to my website very soon. Okay, so scientific notation. What it is, I have 4 different examples of things written in scientific notation. The first one is population of humans on Earth, which scientific notation is 7.0 times 10 to the 9th. The speed of light in kilometers per hour, we write that as 1.08 times 10 to the 9th. The size of a single red blood cell in centimeters, that's very small. That's 8.0 times 10 to the negative 6. And the amount of stars in the solar system, which is 1.0 times 10 to the 10th. So the way that what scientific notation is, it's the way we write really big or really small numbers. So the amount of people on Earth, that's going to be a really big number. So instead of writing out something like 7 billion whatever, we write it in scientific notation. That 10 to whatever power, we're going to explain, or I'm going to tell you what that means very soon. So essentially, the reason we need scientific notation is to write very large or small numbers. And it's just a better way for us to keep track of the number. So instead of having something like 0.000000765, we're going to write it in scientific notation just so we can keep track of just how small that number is. Very large numbers have large exponents. Very small numbers have negative exponents. So the bigger the positive and the smaller the negative tells you exactly how big or small that number is. So what does scientific notation look like? It starts off with a number, a decimal, between 1 and 9.9 in the front. There's always going to be multiplication between the two. Multiplication. And then it's going to be 10 to some power. So as I told, it's always going to be 10. As I said before, that little exponent tells you exactly how big or how small that number is. So what is something not written in scientific notation? If you have time, I suggest you take a minute, pause this video before I tell you. You find why each one of these things is not proper scientific notation. So, the reason why this first guy isn't in proper scientific notation is because this number in front is not between 1 and 10. This guy is in proper scientific notation because this number here is not a 10. You can't have 20 there. And the reason the third guy is in scientific notation is because there's addition between the two. There's a reason why we write multiplied by 10 to some power, and I'm going to get to that. So standard notation, moving on, standard notation is just the numbers we're used to seeing. So the way we turn a number in standard notation to scientific notation, remember, or not that, these guys are scientific notation. So to change a number, we're going to pick a very large number. So something like 3,750,000. Guess that should be under the examples. So again, 3,750,000. The way we convert that number to scientific notation is we're going to figure out where that decimal belongs. In this example, it's at the very, very end. we're going to move it between. So since we want this first number, like these examples, to be between 1 and 9, or 1 and 9.9, we're going to move it over enough times to see where it lands when it's between the first two numbers. So when we move this decimal over, the first two numbers is between 3 and 7. So that's going to be 3.75. We know scientific notation has a multiplication sign between the decimal in the front and the 10 to some power. To figure out that power, we have to figure how many times we moved. So in this case, we moved 1, 2, 3, 4, 5, 6 times. So that exponent is going to be 6. It's positive if it's a very large number. It's negative if it's a very small number. So a very small number would be something less than 1. So something like 0.00000075. That would be a very small number. A very big number is something like 3,750,000, like our example here. Very large number. So the steps to solve this, the first thing we want to do is you want to there we go. Move the decimal. I'm going to make this smaller if I can. Move decimal between first two, and I'm going to use the number symbol. Move the decimal between the first two numbers, like we did in the example. Our second step is to count how many times the decimal moved. And that's our exponent. So that's exactly how you turn a number from what we're used to into scientific notation. So a lot of the times we use scientific notation when numbers are really, really, really big. So something when you would have an exponent of 23, where you would have to physically count out the zeros. It makes it easy for scientists to write very large numbers. So let's talk about how we would go backwards. So when we're given a number in scientific notation, so something like 2.76 times 10 to the 8th. Ooh, pretend like that 8 is an exponent. Okay, so what we're going to do is we're just going to write out that decimal in the front. We're going to take this exponent here, we're going to count. We're going to move that decimal that many times to the right. If it's a very large number, or if it's a positive exponent, that means the number is going to be very large. So we're going to want to move that decimal to the right 8 times. So we have 1, 2, 3, 4, 5, 6, 7, 8. And you're going to fill in all those missing bumps with zeros. 3, 4, hard to see. 2 more zeros there. 1, 2. Okay. So that final number, let's write it out neatly on the bottom. 276, we have 1, 2, 3, 4, 5, 6, 7 zeros? 6 zeros. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. So that is our number written in standard notation like we're used to. So the steps now to converting a number in scientific notation to what we're used to. The first thing we're going to do is write the decimal and move we're going to move it right or left exponent number of times. So remember, how do I get to the end of this text box? All right, I'm not going to write this down, but you're going to just remember it. If it's a very large number, you're going to move it to the right because that's going to make that number have a lot of zeros at the end, which makes our numbers very big. If it's negative, that's going to make our number very, very small. So that's going to make, when our exponents are negative, that's going to make our number very small. I want you to try the back page on your own. I'm going to post a key to this on my website so you can check it on your own. If you have questions, please reach out and ask. I know online learning is not always ideal because you can't ask questions to me right away. So please feel free to shoot me an email, message me on the Remind app, whatever you need to do. We can set up a video conference if you're really struggling. Just make sure you reach out for help. All right? Well, thank you for joining me for our first online lesson. Have a lovely day, and we will talk soon.